Have a look at this grammar, this particular grammar. Algebra is this one. No? So my question is whether this grammar is LR0 or not, SLR1 or not. So I want to find out whether the given grammar, this one, is this grammar 1, LL1 or not, 2, LR0 or not, 3, SLR 1 or not. I want to find out these three things. Okay. So first thing is I want to find out whether it is LL1 or not. So how can you find out whether it is LL1 or not? You know, when a production is having a variable is having two alternatives, find the first of this. So this one is going to be placed under D. This one is going to be placed under A. No problem. This one is going to be placed under B. C. No problem. B. C. No problem. Therefore, this grammar is definitely LL1. You please refer to the video where I discussed about LL1. Okay. And next one is coming to the next one. I want to find out whether the grammar is LR0 or not, SLR1 or not. So you have to note one thing, you need not actually construct the parsing table in order to see whether there is shift reduce conflict or reduce reduce conflict. You can construct the canonical collection of LR0 items, and in this canonical collection itself you can find out whether there are conflicts or not. So there are two types of conflicts. One is SR conflict and other is RR conflict. So whatever the conflict is, reduce move is definitely a must, which means we get the conflicts only in the states which are having reduced moves. So after constructing the canonical collection or while constructing it, whenever you get a reduced move, which means a final item, you have to stop it and check whether there is a conflict or not before going ahead, right? So you need not construct the entire parsing table, you can construct the canonical collection of LR0 items and then go into the states where there are final items. See this? Actually this is not a final item, I1. The reason is this is augmented production which we added. And coming to this one, I9, there is a final item. There is only one final item, which means there are no RR conflicts. And second thing is there is no shift move, therefore there is no SR conflict. Therefore there is no SR or RR conflict in this production. Now coming to this I4, there is a final item. This is a final item and this final item is only one final item, therefore there are no RR conflicts. And second thing is there is no shift move in this, therefore there is no SR conflict, no SR conflict and RR conflict. And coming to state I6, again there is only one reduced move and there is no shift move, therefore there are no conflicts. I7, only one reduced move and there are no shift moves, no conflict. And then I11, only one reduced move, I10, only one reduced move. Therefore in these states wherever you have seen the final items, we don't have actually conflicts, right? Therefore the grammar is definitely LR0. Yes, the grammar is LR0, and if the grammar is LR0, it will definitely be SLR1. The reason is if there are no conflicts in LR0 and by reducing the number of reduced moves you will not add any more conflicts, right? So if a grammar is LR0, it is definitely SLR1. So what I did is, for this grammar I constructed the canonical collection of LR0 items. How? We discussed it already. You start with s-derives.s and then you keep on adding them. And in this example, one point worth noting is s-derives.s. If I apply closure to this, I got only two productions, two LR0 items. I didn't get A and B. The reason is we don't have dot in the beginning of A. So these two productions are not going to give me either A production or B production. So many people generally they write all the productions here. They write all the productions here and then try to expand it. That is wrong. You have to see that whether it is needed to add A production and B production. They are needed only when you get them in the closure. Okay. So this grammar is actually both LR and LR0, SLR1 as well as LL1. So let's see some other example. Let's see one more example. Let us see whether this grammar is LL1 or not. I want to find out whether this grammar is suitable for LL1 parser or LR0 parser or SLR1 parser. So we have already seen that this grammar is not suitable for LL1. The reason is, if I see first of this, it is going to be A, which means it has to be placed under A, and this one also has to be placed under A. So both two productions are going into the same cell. Therefore we have already seen that it is not LL1, and in fact the grammar is ambiguous grammar, and ambiguous grammar is not suitable for any of the parsers. So even it will not be LR0 or SLR1. Just see the example. Now construct the canonical collection of LR0 items, starting with augmented production S dash derives dot S. Then we have to add all the S productions, which means S derives dot A or dot small a, and then A derives dot small a. Okay, and now we have to find out transitions on S. On capital S, transition is S dash derives capital S dot and on small a, S derives A dot, A derives A dot, and on capital A, S derives capital A dot. Okay, now if you see this is not a reduce move, it is a final item which is augmented, and this is a reduce move. But then in this state we have got two reduce moves. Whenever we got two reduce moves in the same state, two final items in the same state, definitely the grammar is not LR0. Now check whether the grammar is SLR1 or not. How can I check whether the grammar is SLR1 or not? Where are we going to place this production, this reduce move, under follow of S? So what is follow of S? Follow of S is dollar. And where are you going to place the second production? This one under follow of A. What is follow of A? Follow of A is nothing but follow of S, which is dollar. Therefore, under the same entry, I might have to put two reduce moves. Therefore, it is not SLR1. So the given grammar is not SLR1, as well as the given grammar is not LR0. Okay, but the given grammar is not LL1 also. In fact, this grammar cannot be passed by any of the parsers. The reason is it is ambiguous grammar. Okay, let's see the next example. Let us see one more grammar. This grammar, whether this grammar is LL1 or not, you can have a look at it. You can pause the video and have a look at it. And this grammar is whether I want to find out whether it is LL1 or not, first thing, and then whether it is LR0 or not, and then whether it is SLR1 or not. I want to find out these three. So first of all, I want to find out whether it is LL1 or not. If you look at the grammar is left recursive. Any left recursive grammar cannot be LL1. Therefore, this grammar is definitely not LL1. And next one is I have to find out whether the grammar is LR0 or not. In order to find out whether the grammar is LR0 or not, we have to find out canonical collection of LR0 items. This is the canonical collection of LR0 items, right? And how to start with? We have to add a production which is called augmented production, and then take the closure of the LR0 item. Okay, so I'm going to add the production S dash derives dot S, and with a dot in the beginning of S. Therefore, I got the closure as this. And if you observe it, we are not going to get all the productions here. Same as the previous example. We are not going to get all the productions in the state I0 or in the starting state. The reason is there is dot to the beginning of S. That is why I added all the S productions. And now there is no dot to the beginning of L, which means we have to add only S productions. No L productions are added. And once you see the transitions, what are the transitions out of this state? There is a dot to the beginning of S, therefore there will be a transition on S. There is a dot to the beginning of open brace, therefore there will be a transition on open brace. So on open brace, I have to apply the transition. That is why I got S derives open brace dot L close brace, and again you have to apply the closure. After the transition, I have to apply the closure. What is closure? Since dot is to the beginning of L, I have to add all L productions with the beginning with a dot in the beginning. That is why I added this production and this production, because of this L, right? So because of this L, I added these two productions, right? And now if you see one more production, there is one more production with the dot before S. Therefore, because of this S, I have to add S productions. That is why I added all these S productions, right? And now if you look at the dot, there is a dot to the beginning of L, therefore there is a transition on L. There is a dot to the beginning of L, therefore there is a transition on L. Both these two transitions on L will go to the same state. The reason is this is always a DFA. Okay, so on L we get two transitions, not just one transition. That is important in this example. Till now we haven't seen any example in which there are two transitions on a single symbol. So on L we have two transitions, right? So we got two transitions. Okay, and on S there is one transition, and on open brace again there is one transition, and we get the same state. That is why on open brace I am writing this. Okay, now if you look at this, on L dot will be moved to the right of L here, I got this one, and dot will be moved to the right of L here, I got this one. Even if I apply closure, I get only two transitions. Okay. Now this one on close brace, I got this one on comma, you can fill it up. Okay, so it is all straightforward from now on. Now I have to find out whether the grammar is LR0 or not. When will a grammar be not LR0 or when will a grammar be not SLR1 is whenever there are conflicts. What are conflicts? SR conflict and RR conflict, which means if there has to be any conflict, there has to be reduce move. What is a reduce move? Final item. Therefore, go to the states where there are final items. This is not a final item, this we added it, therefore this is used for accepting, actually not final item. Are there any final items in this state? No final item. Are there any final items in this state? No final item. Any final items in this state? No final item. Final item is dot in the rightmost. Yes, this is a final item because dot is in the rightmost. Now in this state, are there any shift moves? No. Are there any other reduce moves? No. There is only one reduce move, therefore no conflict. Are there any final items here? No. Yes, this is a final item, and in this state, are there any other reduce moves? No. Or are there any other shift? No. Therefore, no problem. This is a final item and there are no other reduce moves, no other shift moves, no problem. Final item, final item. So wherever there are final items, there is no shift or reduce in that state. Therefore, the grammar is LR0. And any grammar which is LR0 is by extension SLR1. So this grammar is both LR0 and SLR1. Okay, we shall see one more example. Let's see a simple grammar. E derives E plus T or T derives I. This grammar is nothing but the expression grammar, which which derives all the sum, which means I plus I plus I plus I, something like this. Okay, so this is the simplest grammar. And let's see what happens with this. Let us add the augmented production. S dash derives dot E. Then because there is a dot in the beginning of E, I am going to add all the E productions. And now because there is a dot in the beginning of T, I am going to add all T productions, right? And see what happens on capital E. The transition, there are two transitions on capital E. So one transition is S dash derives E dot, and other transition is E derives E plus T. Now if you look at this transition, the first one looks like the final item, which means a reduce move, and the second one looks like the shift move, right? It is a reduce move and this is the shift move. Therefore, you might think that this is SR conflict, but one point here you have to note is this augmented production is the production which you added, right? Therefore, this cannot be a reduce move, this is actually accepting move. If you think that you get confused because of such states, it is always suggested that you add dollar at the end of the first augmented production. The reason is always the starting symbol will be followed by dollar, therefore input can be generated by E and then dollar will be generating the dollar. So even since we are going to give the input as input followed by dollar, this E followed by dollar is going to generate input followed by dollar. That is why it is suggested, right? It is just a recommendation. If you want to follow it, you can follow it, because you might get confused otherwise. So in all the previous examples, you can add a dollar. Now what happens is, this is now not a final item, isn't it? This is not a final item and this is not a shift move. Now there is no conflict here. Therefore, on dollar only, it is going to be S dash derives E dollar dot. We got this. So there is no problem with this state. This is not a SR conflict, right? And on plus, if you see, we are going to a next state, and here also there is no final item, therefore there are no conflicts. On T we got this, there is a final item, therefore it is a reduce move, but then it is a single reduce move, therefore there is no conflict. No conflict, no conflict. This is a simple grammar where there are no conflict. Now let's see what if the grammar is right associative. Right associative means instead of this simple grammar, I'll just change the associativity and then let's see what happens with that. Okay, we shall see it next. Let's see a simple grammar. This is the same grammar as previous one, but then instead of this left recursion, we have used the right recursion. Okay, so first one, what is this grammar? This grammar generates all I plus I expressions like this, right? Simply I or I plus I or I plus I plus I or something like this. Now since E is defined as right recursive, here plus is defined as right associative. Previous grammar E is defined as left recursive, therefore plus is left associative. I didn't do anything, just I changed the recursiveness, that's it. Okay, and now my question is whether this grammar is LL1 or not. It is not left recursive, therefore let me check whether it is LL1 or not. Where are we going to place this production? In the E row in first of T. What about this production? This is also in the E row in first of T. Therefore both of them are going to the same symbol, which is I. Therefore this grammar is not LL1. You can check it. I know if you remember LL1, you can check it. Since both the productions are going to the same cell. Why? Because this one has to go into E row into first of T, and this one has to go into E row and first of T, and since first of T and first of T are I, both the productions are going into the same cell. Therefore this is not LL1. And now next thing is whether it is LR0 or not. In order to find out whether it is LR0 or not, we have to construct the canonical collection of LR0 items, right? So this is the canonical collection of LR0 items. E dash derives dot E is the augmented production. Because of dot at the beginning of E, I am going to add all the E productions. And now because of dot at the beginning of T, I am going to add all the T productions, right? And now one interesting thing is here on capital T, the transition is E derives T dot plus E and then E derives T dot. This is a final item and there is a shift move, right? And because of this state, there is a conflict. There is a shift move on plus, therefore this is shift, and there is a final item, therefore it is reduced. Therefore in this state we have SR conflict. If you want to see that in the table, in this table, you can see that in the second state I2, in the second state I2, under the cell plus, under the plus, there is a SR conflict, and the reduce move is R2. Okay, how do you place reduce moves? Let us say we have numbered the productions. Production number is 1, production number 2, production number 3, and if you see this I2 state here, the final item corresponds to the production E derives T, which is 2. That is why I am going to write R2 in that row. So according to LR0 parsing table, I have to place the reduce moves in the entire row. That is why, see this, in the I2, in the state 2, since there is a final item, I am going to place the reduce moves in the entire row, right? And in the I3, since there is a final item, I am going to place the reduce move in the entire row. In I5, again there is a final item, therefore I am going to put the reduce move in the complete row. Now where did the conflict arise? The conflict arises here, and this table is LR0 parsing table. You need not actually construct the parsing table to show that the grammar is not LR0. Here itself we can stop and say that since there is SR conflict, the grammar is not LR0. Now my question is, yes, this grammar is definitely not LR0. Now my question is whether this grammar is SLR1 or not. How to find out whether the grammar is SLR1 or not? What is the main difference between LR0 and SLR1 is, in LR0 reduce item is placed, reduce move is placed in the entire row. In SLR1, reduce item is placed, reduce move is placed only in the follow of left hand side, which means this R2 corresponds to second production. What is the second production? E derives T dot. This is what is R2, right? R2 corresponds to this production. Where should you place it is only in the follow of left hand side. What is follow of left hand side? E. Therefore in SLR1 parsing table, we are not going to place the reduce move in the entire row, we are going to place it only in the follow of left hand side. Now tell me what is follow of E. Follow of E is, according to the grammar, follow of E is, since it is the start symbol, it is dollar. Okay, and follow of T is, since it is the here T is followed by plus and dollar. How to find it out? We know that, right? Now the production E derives T dot, where the left hand side is E, has to be placed only in the follow of left hand side, which is nothing but dollar. Therefore R2 is not placed all over, R2 is placed only under dollar. And next one is, look at the third production is T derives I. So T derives I has to be placed only under plus and dollar, which means you need not place it here. And next one is fifth production is E derives T plus E. Where should this be placed? Only in the follow of E. What is follow of E? Follow of E is dollar. So this is nothing but SLR1 parsing table. So what is the difference between SLR1 and parsing table and LR0 parsing table? In SLR1 parsing table, we are going to place the reduced moves only in the follow of left hand side. In LR0, we are going to place the reduced moves throughout. So that is the main difference. Now, if you look at this, the grammar is now SLR1. The reason is there is no conflict. The grammar is definitely SLR1 but not LR0. Okay. So we shall see the next example.